Dear students, in the last class we discussed about the properties of matter. In the properties of matter, the first property what we are discussing is surface tension. What we are discussing is surface tension. And we know surface tension is the property of a liquid. Surface tension is the property of a liquid due to which the surface behaves as a stretched membrane. Due to this property, the surface behaves as a stretched membrane, right? So in the last class itself, we discussed that the molecular theory of surface tension. Molecular theory of surface tension. How, why the surface tension is created, and which direction the surface tension is there, and why it is happened. These are all the things we discussed, right? Now we will try to understand the mathematical expression. We will try to understand the mathematical expression. See here, for example, we know that here, see here, one container is there here. Container is there, and I wrote here up to here liquid is there. Liquid. If you will see the upper view, the liquid will be like this. Container is a cylindrical one, na? So upper view the liquid will be like this. So here all liquid particles will be there, right? Liquid will be there. So now mathematically surface tension how we are defining? Just imagine one line here. One line of length L. Length is how much? L. When we consider a imaginary line of length L, so on this side one particle will be there, on this side one particle will be there, right? Clear? So due to the remaining molecules, there is force of attraction. Force of attraction. That what we discussed, it acts as a stretched membrane. When it will act as a stretched membrane, from here one force has to act, from here one force has to act. Then only it acts as a stretched membrane. So in this situation, not only at this point, at these 2 points, these 2 points, these 2 points, these 2 points, now everywhere force is acting outward. Force is acting outward. So mathematically, surface tension is defined as force acting per unit length. How to define? It is defined as force acting per unit length. So surface tension generally denoted by ST. Generally denoted by ST, or generally we can write it is T. T is nothing but tension. But here the tension on the surface of the liquid. Tension on the surface of the liquid. That's why we are calling this surface tension. Surface tension can be written as force upon length. Force upon length. So SI unit you can write. SI unit. SI unit is Newton per meter. Clear? Easy only. What is surface tension? Generally, mathematically, surface tension is defined as force acting per unit length. So we have to write tension T is equal to force upon length. And one more thing we have to understand, surface tension always acts on the free surface. On the free surface. It is not, see in the last class itself we discussed, inside the liquid, inside the liquid, there will be no surface tension. If the outer layer is exposed to air, then only we are observing. Clear? So for the free surface, absolutely surface tension will be there. For the free surface which is exposed to the other medium like air here, there will be some surface tension. Second point, surface tension is always acting tangential to the surface. Surface tension always acts tangential to the surface, to the liquid surface. Clear? For example, here it is there. So surface tension will be acting tangential only. It is not perpendicular. It is only tangential. Tangential to the liquid surface at that point. Tangential to the liquid surface at that point. Clear? And one more thing, it is a scalar quantity. It is a scalar. It is a scalar quantity. And again, surface tension depends upon the nature of the liquid. Surface tension depends upon the nature of the liquid. Surface tension depends upon the intermolecular forces of the liquid. Intermolecular forces of the liquid. Clear? So try to understand these points. First thing, surface tension is a scalar. Second one, it acts always tangential to the surface. Tangential to the liquid surface. And third one, what is third one? It depends only on the nature of the liquid, or we can say it depends only on the intermolecular force of the liquid. It does not depend upon any object or any mass. It depends only on nature of the liquid. Clear? Clear? Now see here. But try to understand this one. Here on the liquid surface, 1, 2, 3, 4, 5. 5 different objects are placed. How many? 1, 2, 3, 4, 5. One is a rod, second one is a thin ring, and third one is it is a ring, but internal radius and outer radius is differs, and this is a disc, and this one is a rectangular plate. See here I will write it is a rod of mass m and thin ring of mass m. All are identical masses, right? Only for general understanding purpose. So here it is ring and having R1 and R2. R1 and R2. R1 is the internal radius and R2 is the external radius. Outer radius also we can able to say, right? And this one is, and mass again m, and this one is disc of radius r and mass m, and it is rectangular plate of mass m, and the same thing square plate also we can able to apply. Now the basic questions what he will ask. So now these are placed on the surface of the liquid. Clear? Now we will ask that find the minimum force so that I can able to lift the bodies up. Try to understand. So here, how much force I have to apply? Minimum force I have to apply so that I can able to lift the bodies. Clear? We'll try to understand. So first one is rod is there. For rod we'll discuss. Rod is this one, right? Rod is placed like this. Just try to understand. If you redraw the diagram will be this one. So I can able to I will draw this one, right? See here. Correct? So now for this rod, downward mg is acting. Downward mg will act. So I want to lift upward. I want a minimum value. When I am going to lift up, the liquid surface, how it will form? For example, if this one is there, I want to lift upward. So initially there is a contact, right? Liquid contact is there. So all the liquid surfaces will form like this. Clear? Why? Because I am lifting the rod. Like this. So here also some liquid surface will be there. Here also liquid surface will be there. Correct? When the liquid surface is here and here, then automatically tension will be developed. So tension through this one and tension at this point also it will be developed, right? So now see here, due to this liquid, we know tension will be downward. Tension. If tension is downward, what is force? How much of force will create? We know that tension is nothing but force per unit length. Force is equal to tension into length. So I am considering this length of the rod is L. So length of the rod is L. So this side downward tension into length, and this side also downward tension into length. Don't get confused. Why? Because here also free surface, liquid surface is there, and here also liquid surface is there. So when I am going to lift from this side, tension into length, and from this side tension into length acting downward. Clear? That means here force due to tension downward, force due to tension downward, mg downward, F minimum upward. So here it is. I will write the tension to length, and again here I will write tension length. Mg is downward. The same thing I want to draw here. So when I am going to lift here, due to liquid force now, I will write here at this point tension into length, and at this point tension into length. Clear? Tension into length is nothing but the force. So now if I want to lift, the minimum force should be, what's the minimum force? The minimum force, it has to balance these forces. So F minimum can be written as TL plus mg plus TL. So I will write mg plus 2 into TL. This is the minimum force, right? How much force it is? How much force? F minimum can be written as mg plus 2 times tension into length. Am I clear? Now see the second one. What is second one? Second one is ring. Second one is ring. So it is a thin ring, right? Thin ring I will write. Thin ring. So for the thin ring, see, I will draw the bigger here. After that I will try to write the expression, right? Here thin ring is there. So for the whole ring, mg is acting downward. Mg is acting downward. And I want to apply F minimum. So when I am going to lift, then automatically surface tension will pull down. So due to surface tension, how much force will be there? Tension into length. So tension into length means here how many surfaces which have contact with the air, with water. So here see, here it is water is there, and here also water is there. Correct? So for this outer surface, downward tension into length, and for inner surface also downward tension into length. What is L here? Length of the ring. Length of the ring. So what is the length of the ring? Which is nothing but the circumference, which is equal to 2 pi r. So here, in order to lift the ring, so I will draw here small diagram, try to understand here. Here ring is there. I will write here F minimum, downward mg. So here TL for the outer edge and for TL for the lower edge. So here we can write F minimum can be written as F minimum can be written as see here mg plus 2TL mg plus 2TL. Again I will write F minimum can be written as mg plus what is 2TL? 2TL. What is L? L is nothing but the circumference. What is circumference here? 2 pi r. So I will write 2 pi r. 2 pi r. If you write like this, then how much you will get here? F minimum can be written as mg plus 4 pi tr. 4 pi tr. So in order to lift, the minimum force will be mg plus 4 pi tr for the ring. Clear? So I will write it directly here. We will try to understand. Here I will write F minimum is equal to how much you will get? Mg plus 4 pi tr. This will be the minimum force. Clear? Now see, for that ring having internal radius is r1, outer radius is r2. Internal radius is r1 and outer radius is r2. For this, see here, this one, and here try to understand. Here liquid is there, and here also liquid is there. Clear? So now downward mg will act, upward F minimum, and from due to this contact here TL will be there, and this length is different. I will let TL1, TL1, but because this circumference, outer circumference is different and the inner circumference is also different, that's why I'm writing TL1, and here it is TL2. I will write TL2. So now we can write F minimum can be written as we can write mg plus TL1 plus TL2. So F minimum can be written as mg plus T will take common L1 plus L2. T will take common L1 plus L2. So we'll get here F minimum can be written as mg plus T into L1. L1 is nothing but 2 pi R1. Outer radius is, for example, outer radius we are giving as R2. 2 pi R2 plus 2 pi R1. 2 pi R2 plus 2 pi R1. Here also 2 pi is there. We'll take common out. So F minimum can be written as mg plus 2 pi T into R1 plus R2. Am I clear? F minimum is equal to mg plus 2 pi T R1 plus R2 is the minimum force which we have to apply to lift the ring having internal and outer radius. Am I clear? Now we'll see disc. Here I will arrange. There is no other option for us, right? So I will arrange here. See disc. See disc. Disc is this one. And now you tell me how many contact areas are there? Only contact, right? So now here downward mg, upward F minimum, and here liquid is there throughout the surface, throughout the outer liquid is there. So downward I will write T into L. T into L. Why? Because we know surface tension is equal to force per unit length. Length is nothing but the length of the body which is in contact with the liquid surface. Which is in contact with the liquid. So here how much it is? TL. So I will write minimum. F minimum can be written as how much it is? mg plus TL. So here F minimum can be written as mg plus T. L is nothing but circumference it is. So which is 2 pi R, where R is the radius. So this is the minimum force required to lift the disc of mass m and radius r. Clear? Now see here, last one, plate. We'll see plate here. Plate, we'll see. Plate. Here, now plate is like this. Whether it is a rectangular or a square depends upon the numerical. Just I will consider it is a rectangular plate, so that length and breadth will be different, right? Having length here L and breadth B. So it is a rectangular plate, right? And here liquid will be there. Here liquid, here liquid, here liquid, here liquid will be there, right? And here also liquid will be there. So now downward mg will act. Upward F minimum. F minimum. So try to understand. This surface is contact. So downward TL. Tension into length. This surface is contact. Downward T into B. T into P. But because the length is nothing but B here. That's why I wrote B. This surface is also contact. So downward, again T into B will come for this surface. And this side is also down. So downward T into L will come. But because opposite sides are equal. So if you see, the minimum force can be written as F minimum can be written as one is mg plus this TL and this TL. So 2TL plus this TB and this TB. It is 2TB. So this will be the minimum force to lift the plate having length L and breadth B. Clear? I hope you understood, right? So further we discuss in the next class. Thank you.